Hi guys, I'm going to talk you through Fusion 360. I'm going to take it from the start, going to draw up a little model very similar to the second model that we did in SolidWorks CAM, and you can compare the two processes. But it's similar, the steps are pretty similar. We're going to draw a sketch, extrude it, draw another sketch, and do an extrude cut. And then we'll put in a few holes, and from there then we'll go to the design and we'll set up the CNC machine, set up the different CNC operations, pick up our tools, set up our stock, and then run the simulation. So let's kick off. So I'm in the design tab here, which is where you do your drawing in Fusion, and the first icon here is create a sketch. So I'm going to press create sketch, and I'm going to press on the bottom plane here, and that brings me into a 2D mode. And I'm just going to pick up the rectangle, and from the origin I want to go up 50, and then we'll go out 70. So let me just put a dimension on that, out 70. Then you finish the sketch, and you can either press extrude or press E on the keyboard, and then you can pull up your piece. So pull it up to 10 millimeters and press OK. And now I want to do a new sketch on the top. So again, I just press on the top, and this time I want to draw in a slot. So I will put in a center to center slot from here to here, and we'll make that 10 mil. And another slot. Now you can pull down and click slot again, or you can, if you like, right click on the mouse and drag it to the. No, you can't do that. Sorry. There we go. So we go and press start again and drop it down. Now I'd like to put a few dimensions on this just to make sure it's what I'm looking for. So let's make this guy 50, and this guy here we'll make 30, and this side up, that's 25, that's fine. The edge in, let's make that 10. The grid is handy. If you're working in increments of 5, you can just use the grid and snap to it. As you zoom in and out as well, the grid will get finer or coarser depending, and the scale here will update. So it can be quite handy. It's nice little feature. Now we'll put in a few more dimensions. So I would like that to be radius 5, and from the center line to the center here, 15. Okay, I think that will do it. Now I'm going to trim. So press the trim tool, little scissors, press and hold the left button on your mouse, and trim off the little lines here. Happy with that, we can end the sketch. And again, we press extrude, and you can, if you press the outside, it will either add or cut whatever you have on the outside. Or if you click the inside, it will add or cut. So if I press the inside and I pull up, now it's going to add to the block. Or if I pull down, it's going to cut into the block. So it's quite clever and intuitive. So I'm going to go down 5 mil, press OK. And now I'd like to fillet the 4 corners here. So I'm going to press the fillet, click on the 4 corners, and we'll go with 10 millimeters. So that's a little feature I'm looking to machine out. Now I'd also like to put in a couple of holes in each corner. So you press on the hole command. You can set up your hole here. So I'm going to go with a simple hole. And if I press the top surface, the hole will be presented or positioned on the top surface. And over here I can set the diameter and so on. So I'm going to use a 6mm hole. And then to place it in, you press an edge, and that will give you a reference from that edge. So let's say 10mm and 10mm. Now I can reactivate the hole command by pressing the right button on my mouse and dragging it down at -45 degrees. So I drop down here, click on the edge, say 10, 10, and 10, 10, and then finally this one here, 10 and 10. Okay, so that's the part as I would like to have it machined. So now I'm going into the design aspects or the manufacture. So I press on design, scroll down here to manufacture, and when I get to manufacture, the first thing I need to do is set up the machine. So click on setup, select the machine, and I'm going to go with the Autodesk generic 3-axis machine. But there is other machines available, and you can download specific machines from the Autodesk website. But that's fine. Press select, and now mill is selected. That's fine, and we need to set up the work coordinate system. And you can see here the Z-axis is facing the wrong way for a CNC machine. So what I'm going to do is pull down the orientation, select Z-axis, plane, and X-axis. And when I do that, I'm going to pick a vertical line, and that will reorientate the Z-axis. Now the position of the Z-axis, I can put it on the stock box, or I can put it on the model box, or I can select a point. So I'm going to go with the stock box, and I'm just going to select that point. So over here, yeah, so the stock point, which is here, you can see that axis moves around, and I could move it to different locations. And so if I like it on the center or on the top left corner, which is where I'm going to leave it. Then we go to stock, and keep the relative size box here active. There is other options. You can go to fixed size box, fixed size tube, from the solid, and so on. So we'll go with relative from the model that we have here. And I would like to add 0 to the sides, and I'm going to put 5 onto the top just so we can do a facing operation there. So press 5 and then press OK. So here we have the machine set up, and we have our stock set up. And then what we want to do is go through our different operations. So unlike SolidWorks CAM, where we had the automatic feature recognition, here what we have to do is build up the different operations ourselves. So you need to know a little bit more about the machining and the machining process to get through it. So what we're going to do is press on the face. The first thing you got to do is select your tool. If I scroll down to tutorial mill or metric, and there's one facing tool there. It's a 50mm diameter, so it's quite a big facing tool, but I'll select it given it's the only one I have. So select that, press OK. Now in the next couple of tabs you can select the geometry and the different heights that you're going to work from. So here we can see the bottom, the top of the piece, the retraction height, and the clearance height, and we can set all of these in here. So I'm not going to change them now, but we will come back to them optimize the process in a few minutes. Okay, next up we're going to do a 2D adaptive clearing. So we're going to clear out the inside of this pocket. So press 2D adaptive clearing. Now we've got to change the tool. So select the tool. Again, head down to tutorial metric. And we will take a 5mm flat end mill. Press OK. And in the geometry tab, just press the base of the feature. And for the moment, I'm going to press OK, and then we'll come back and just look at some more of the detail. We'll press OK, and you can see the toolpath has been generated there. You can see the spiral in, and you can see the toolpath. So if I go to simulation now, so if I click on the 2D adaptive function and simulate that, it will only simulate that particular piece of it. If I click on the face, it will only click on the face, or it will only simulate the face. So I'll go to the full setup and right click and then press simulate. And down at the bottom here we can press play. So we can see the facing tool coming in. Face is the top of the part. We have a tool change, and then we're spiraling in, and you can see the height that we're spiraling in from is quite high, and that's because it's taken it from the stock and not from the actual model. And given that we've just faced it off and we've taken 5mm off it, we're now going to go back in and just update the offsets here to take that into account, because there's no need for us to be spiraling in from that height. It's just inefficient from a machining point of view. This little slider here, if you move it to the right, it will speed it up, and if you move it to the left, it will play it in reverse. It's quite a handy little tool. You can jump to the next move, or jump to the next operation here, or jump to the end. So I'll just jump to the end there, and we can see the toolpath, and we can see that there's a certain amount of material left here, and that's because the 2D adaptive function is a roughing function that's gone in there to rough out the material as quick as it can under full tool load. And now what we want to do is to put in a 2D contouring operation to finish this down to tolerance. Now, so I press close to close end the simulation. I want to update the heights, as we said, for the adaptive function. So I'll right click, press edit, and the geometry, or the heights, okay, instead of the top of stock, I would like to change that now to the model top. So change that to model top, and if we press OK, it will update the toolpath, and you can see the spiral here is a lot shorter. Now, one of the handy features here in Fusion is, instead of clicking here and going to get the new 2D contour and setting up the heights and setting up the tool again and all that, you can right click on the process here, and if we scroll down and create a derived operation, and it's a milling operation, and this time what we want is to create a 2D contour. Click that, it's created it. You can see the tool has been brought in here, the heights and so on, and if you have any feeds or speeds, they're also brought in here. So if I press OK, and that creates that toolpath, and as you can see, it comes down and cuts out the contour, takes off the excess material that was left from the adaptive. Now, next up, we would like to drill out the holes. So there is a handy function here, the hole recognition. It is an add-on, but it is available to students. So if initially you go in there and you click it and it's grayed out, just go through the process of activating the add-on. So it makes it, it automates it a little bit more, makes it a little bit easier. So I just click the hole recognition. It's picked up the hole. It knows it's 6mm diameter, spot drill and drill a hole. So that's the action that's going to take. It's going to spot drill them and then come back with a drill and drill it. Press OK. And that's pretty much the machining from a straightforward point of view finished. We'll come back and we'll refine it, as I said, but let's go back to setup here. And we will simulate the toolpath. And play. Oh, my mistake there now, I didn't go back to this to the setup. So what it's doing here is it's just doing the holes. So I'm going to stop that, close that, go back up to setup, and now press simulate. And then we're back to the start. I'll zoom out here a little bit. You can press the little home button here, or you can look at the front face or the top or whatever. So very similar to SolidWorks in that regard. So let's play it from the start. Incidentally, the toolpaths that are shown here, the yellow is the transitions, and then the green is the feed in and out of the piece, and the blue is the cutting. So if we just run that, you can see the yellow line, which is transition, the green is feeding in, and then the blue is cutting. So now we're spiraling into the piece. Speed this up a little bit. Then we'll change into our contour milling. Then we'll do our center drilling and we'll drill the 6mm drill. Okay. Now you will see here that, and you will see this in practice, that when you contour around, and if you contour around with a 0 offset on the vertical axis, then you'll end up with this kind of marking of the floor of the piece. So we're just going to go back into the settings, change it slightly, and see can we improve that. So close that down. We're going to take a look now at refining the operations a little bit. So we'll go into the adaptive mode, right click, press enter, or edit, sorry. The spindle speeds and so on will come directly from the tool manufacturer. I'm going to take a look here at the passes and the tool loads here. Now the optimum load, now this again very much depends on the condition of your machine and so on, but it's generally given us 20% of the tool diameter. So our tool, we're using a 5mm end mill, so we can check that here. So the 5 diameter 5mm flat end mill. So here what I'm going to do is put in 5, and you can, very handy, you can put in the numerical expression here to calculate it out for you. So 5 by 0.2, so that's going to bring it to sorry, I pressed enter there, let me go back in, edit, to 1mm. You remember previously it was 2. Now the other thing I'm going to take a look at is the radial stock to leave. 0.5 is quite a lot of stock to leave. This is what it's going to leave around the circumference of the cutout. So I'm going to bring that back down to 0.2, and the actual stock to leave I'm going to put in a 0, because I want it to come down and cut the base. And quite often when you're machining, when you have an adaptive cut, that the base or the floor of the cut is quite sufficient on the adaptive. So press OK. Next up, I'm going to try refine the 2D contour. So we'll right click, press edit, and again we will go to the passes, the the thing we want to look at here is the stock to leave. So I click on stock to leave, the radial. Now I want to leave 0, so I don't want anything left. I wanted to get as close to the side as I can. But on the bottom, the axial, I want to just come slightly up off the bottom. So I'm going to put 0.01 in here. And what that will do is it will just keep the tool off the bottom, and you won't get the score marks around the circumference on the base of it. So press OK. And let's go to a simulation and see what that looks like. So click on Setup, Simulate, and play the simulation. I'm going to play it quite quickly here. So we're doing our facing, contour milling, or adaptive, that wasn't contouring. You see, we have no longer got that gouge mark that was around the bottom of it. And it won't affect the tolerance of the part to any significant degree. So that's how that's done. Now I'm going to close this simulation. A couple of final steps. We're just going to print out the setup sheets and do the post-processing of it. And the setup sheets are to be used on the factory floor for working out what tools are needed and the tool holders and so on. So you press on the setup sheets here. It asks you for a folder that you would like it to be saved in. So I'm just going to put it into the Fusion 360 folder. Select. It's a HTML file, so it will open in your internet browser. And you can see here it tells you the setup for the stock, the position for the work coordinate system, the total machining time, and the maximum feed rates and so on. So we have a estimated machining time, cycle time here of 3 minutes 58 seconds. And then it tells the operator what tools are to be used for the setup and the operations that it's going to go down through. So you can see here that we have, these are the tools listed. So there's my facing tool, there's my spot drill, and my flat end mill. And then these are the different operations. So we're going through the facing, we're going through the adaptive clearing, the contouring, the spot drilling, and the drilling itself. So nicely laid out there. Now we'll do the post-processing. So the post-processing is done in here. So when I click on here, I need to select the machine and select the vendor it's going to. So I can select a milling machine, click on the vendors. So let's go down to a Fanuc, pick up the setup. So this is a Fanuc with incremental. Remember your G91. So we're going to set that up and then press post. And it will save it, give it a file name, and then save. And that should open up, and what it uses is the Windows WordPad to open it up. And there's your G code for the system, or the circuit, or the program, I should say. So that concludes this podcast. The next podcast we'll look at 3D machining, because this has slightly more functionality than the SolidWorks CAM, and we can do some 3D machining, so some complicated contours and so on, and we'll take a look at that in the next podcast. Thanks, and hope it helped.